So hello, this is Mike Burton from University of Manchester on Stromboli volcano. We're looking at the volcanic gases being emitted by Stromboli from this vantage point, which is at 190 meters above sea level, close to Punto La Bronzo, which I think is the right pronunciation. There's the Osservatorio restaurant, which is always a good place to come for a meal in the evening if you want to see some of the fireworks from the volcano. And here we have a lot of infrastructure monitoring the volcano. And what we see here is the Sierra del Fuoco, which is one of the main collapse scars. It was here that in 2002, 2003, December 2002, that there was a collapse of a lava field that built up during an effusive eruption, and that collapse produced enough impact, enough mass movement into the sea that there was a tsunami which inundated the coast of Stromboli and did an awful lot of damage. Fortunately no deaths, because it was December. If it had happened in the summer it would have been quite catastrophic, but since then they've implemented quite sophisticated methods to try to mitigate that risk, but it was pretty bad at the time. So we're doing these measurements, well, we're here to do some measurements in coordination with a group of other scientists from across Europe and the States. There's a group from the University of Hawaii, the USGS, based in Hawaii, the Hawaii Volcano Observatory, as well as various places around Europe, including Munich, and many people from INGV in Italy, as well as from Oxford and Cambridge in the UK. Today what I'm doing is looking at this rather new SO2 camera system, which is this very compact little instrument here, and this is going to be used to try to image how much SO2 is being released from the volcano up through that white cloud coming out from the summit. And the whole purpose of this is to give us quite fast measurements. This is working at 4 frames per second to allow us to capture fast explosions and fast events when they occur. So Stromboli is famous for its fast explosions, its frequent explosions, which are quite mild, but they're relatively, normally they're once every 15 or 20 minutes, but unfortunately for the field work that we're doing here, obviously volcanoes don't always do what you want, and it seems extremely quiet at the moment with very limited activity, which is not ideal for us, but that's the way things go. Here what we've got is the instrument consists of 2 lenses and 2 filters and 2 cameras. It's all sensitive to the ultraviolet, and that's because that's where there's an absorption from SO2 gas, and all the skylight you can see contains some UV, obviously not too much, otherwise we'd be getting sunburned all the time, and ozone takes out most of the SO2, but most of the low frequency light, high frequency light, and what we do get coming through is some radiation from about 305 nanometers upwards, which is where SO2 can absorb if it's present. And so what we do with this instrument is measure 2 images simultaneously, one at 330 nanometers and the other one, if you can just around see it, at 310 nanometers with each camera. And the difference, the ratio of those two, gives us an image which is proportional to the intensity of which is proportional to the amount of SO2 which is present. And from that we can quantify each pixel in the image to give us a quantity of SO2, and thereby create a good picture of how much SO2 is coming out. There's sort of small rockfall occurring right now, very, very small, but still you can see little rocks jumping down. A very dynamic surface, obviously. And what's novel about this, I mean, SO2 cameras have been around for a while. We did a big workshop on here in 2013. A special issue of that's about to come out, and in JVGR. And this is a 12mm lens, so it's a very short focal length, very wide field of view, and we're very pleased with it so far, because this new instrument gives us a chance to be very close and still give us a wide field of view. So in the next few days I'm going to be taking up to the summit to see the whole crater terrace in one sweep, one image, and hopefully we'll be able to get some nice data from it that way. We can see here the images coming out. Oh, it looks like the memory is full up. So this is the type of images we get, and it doesn't look like much now, but once it's been analysed we'll be able to get some nice pretty pictures of SO2, I hope. Unfortunately the weather is not so good. We've got some a lot of condensation up there, so the people who are up at the summit today are probably not having much fun. I hope it's better than it looks for their sake, because otherwise they're going to be just stuck in the plume all day. But we've got several more days ahead of us, and hopefully both the weather conditions and the activity improve from our point of view. Okay, thanks very much. Cheers.